if I receive the push, right?
Yep.
That shouldn't be the job of the push service, right? That's my application level. I'm telling, hey, I received that, do what I want, right? There are other cases in which, and it's great for battery life and saving network, in which the push service can take this job. It's like, yeah, we know we deliver this, we're gonna let you know, right? When you go to TTL, the time to leave, it will be very hard to implement something that says, hey, it just expired, so I'll let you know, right? You can safely assume, based on your TTL, that never got pushed, right? And then there should always be a maximum cap of time to leave, right? So therefore, you can always assume the message never got delivered. And the reason for a maximum cap is that it often happens that people with multiple devices leave them in the drawer for years, right? And there's some sort of garbage collection that needs to happen. So I'm making an example on our system. We decided that 30 days was enough for you to not use the device anymore, and so that will be your max TTL. Right? In that case, you can always assume sort of.
Yeah, Mozilla is looking at this, at implementing a maximum TTL as well, and so the protocol actually supports this. I think the default TTL is 0, so if you don't specify anything in a request from the application server, that's what you get. But if you specify that I would like a TTL of 7 years, clearly the service doesn't want to support storage of this useless information for that period of time. It actually responds in its acknowledgement saying, no, this is the real TTL, and is required to make that strictly less than or equal to the value that was requested. And so if the application sees something that it doesn't like, because it gets TTL equals 0 on the way back out again, well, suck it up. It really has no recourse at that point, but that's really what we're at. I would like to suggest that people implementing these things have better taste than to do that sort of thing and actually have a sensible minimum. But we can't require that they maintain data indefinitely. I think that's completely unreasonable. Good. Yep.
One small comment. So
name, please.
Costin, Google. So there is a bit of asymmetry between device and server. Device is expected to be offline for a week, no problem.
Yep.
And we support 4 weeks storage. Server, we kind of expect to go back after a day or so. So it makes sense to have different maximum for storage on the upstream ACKs, because if it doesn't go back, the server doesn't go back after a day, then probably they shouldn't be dealing with that. And the other thing is for TTL 0, even if it's TTL 0, you kind of want to still get an acknowledgement reliably, because
yes,
you may want to do things. And one of the main uses of this storage for ACKs is flow control, because you may not be able to handle the same amount of traffic when receiving messages as you are when you send. So even with TTL 0, it's guaranteed you'll drop some messages because you cannot process all of them. So you will need some sort of storage even for TTL 0, in my opinion, of course.
Okay. That will be obviously an implementation concern.
Do we have any opposition to this proposals? I mean, I'm not hearing any objection here. But
Costin suggested that you perhaps might want to cap the TTL on the way back out. My suggestion was if you prepare, my thought on that was if you're prepared to store something for a month, then what's the difference between storing an acknowledgement and storing the message itself? But you may have different math on the cost of operating the service and all those sorts of other things that come into play there. I think on those sorts of timescales, maybe it's not a concern. Maybe we can be a little bit looser on the requirements. Is I guess the point.
My main concern is NACs. I think that NAC should only come from the push server and application server.
Correct.
That is all it does. Wrong. But if we accept the message and we can't deliver for whatever it is and it expires, like there should be no NACs. So 2-3 slides back, when you had like oh, we try to deliver. There's something wrong with the next.
This one?
Oh, this one, yeah. With a user agent, I do not think we should have a NAC, right?
You don't think this is NACable?
I don't think this is NACable.
This is the only case for NAC.
No, the only case for NAC is application server sends something that is wrong, right? And the push service
and
filter the message.
Case you would get a 200 or a 400 level code from the push server saying I'm overloaded, or I don't want to see this message, or it was too big, or any of those sorts of other things.
Okay. Well, I would remove the only case for NAC.
Okay.
Are there other opinions?
Does someone want to speak to this? Because Elio's just off a plane, and he was the one who wanted this. So.
I'm Elio Damaggio from Microsoft. The NACs are makes it a lot easier for the application server to understand how and when to retry. For instance, and I think that the distinction that Martin makes between something that happens because the message is poisonous in a certain way, meaning that the user agent is not able for multiple times to actually acknowledge that message, means that there's something that is tripping up its logic. I do not want the application servers to just send that again. It's not expired because the user agent never came online. It's something that is really nice for the application server to know that that message is not working and it's consuming a lot of resources for no reason. And that's very different from the user that the smartphone was in a drawer.
Andrew, in that case, you're asking for something in the NAC that says that I attempted to deliver it n numbers of times. Yeah?
Well, so to be clear, this isn't the only reason why you might send something like this. The only reason the description of this was the push service gives up for whatever reason. Now, it could be that it's overloaded and has to shed some state, or it was deemed to be poisonous, or I don't know what.
I would like to reply. I mean, what is the use case, right? So if the user agent can't accept the message, it's overloaded, sure. Well, you should retry later, right? It's not just this message. What the application server can do, right? If you're overloaded, then push service to say, hey, 500, wait, right? So I don't think the user agent can say, I'm overloaded for this one message, don't send it again. Second, if it's poisonous.
This is beyond the point that the message is accepted. So this could be a week.
Okay.
Out of your 4. But you're not going to hold the request to deliver the push message open for a week.
So what power are we giving to the application server to be able to create a poisonous message for the user agent code of the push service? Like, the only thing I see is the content is poisonous to the application in the end, right?
That would be the
right. So why the push service is the one saying like, hey, you are writing shitty content for your own app? Like, we're acting at the application level protocol, which is bad, right? It makes no sense. I really don't see any use case in which the user agent, which is part of the push service, tells the push service this is bad as the only case for this message for the application server when everything else is fine.
I won't try to defend this.
This is Elio again from Microsoft. The main reason is that yes, we do want to have an acknowledgement at the application level, and that is deliberate. That is a scenario that we think that is very important, because if you don't do that, you end up. It's true that it's like shitty code, like you put it from the application server and the application, but that ends up generating more traffic and creating in the end more problems. So people unfortunately do write shitty code, and we're trying to avoid to put them in a position to avoid consuming more resources than necessary for that reason. We actually want to provide that service. If you're how somebody writes a reliable message delivery from the application server to their application, it's actually, I think, part of the use of a push service, which does many wonderful things, but this, I think, is one thing that it should solve.
So I'm just going to say something you've already said. I'm going to use slightly different words. Shut me down
Name,
if I
please.
end up taking too long. Robert Sparks. So, and you in particular, Francisco, is who I'm replying to. Application server sends a push to the push service. Push service sends a push to the user agent. User agent crashes. Crashes in a way that the push service can tell, holy crap, I just crashed that user agent. I'm not going to send that message to it again. It'd be nice to tell the application server, don't tell me to send that message again. And that's really what you're talking about.
Joe Hildebrand from the floor. I wonder if there's not another approach you could use for some of this stuff instead of inside this protocol. Like maybe there's out-of-band signaling you could do, like sending the application developer an email saying, 30% of your messages are having this problem or something along those lines.
Unfortunately, that's not going to work particularly well in this context because there's no, well,
I'm just looking. I'm looking for.
But there's no relationship between the push service and the application developer that's direct. If you think about it, the application developer has a relationship with the user. And that's where it ends. I've just sort of pushed a hot button, and I'm aware of this.
So yeah, maybe I'm too down on the implementation of our implementation, but the message contains metadata, right, and the message, right. The metadata is validated at push service. There's no way the push service has metadata that can crash the user agent. So if the message is poisoned, as in the content, which is like you pass through, right, and the application says, only the application knows that the content is poisonous to the application, right. You're saying, yeah, we should try to help developers to not write back code or span the system. Like there's nothing that prevents the application server to do a for loop or while true, send this message continuously. I mean, you're not saving much in the case. So I really don't see how the application server message, like if there is a way for the application server to send a message that crashes the user agent, there's already something wrong. We should have caught it before. Right?
I missed who was next.
Andrew Allen, the fact that the user agent crashes doesn't necessarily mean that that message is bad. It could be you send it any message and it will crash because it can't allocate memory or there's some other basic problem that means that any message you send it is, or any message of that size that you sent it is going to be a problem. So I think there's lots of reasons why user agents might not respond to a message.
Dan Drutzak. There's a reason we call it push service. It offers me a service as an application, and I want to offload as much logic as possible to it. So I'm on Elia's camp with, give me that negative acknowledgement if I need it. I would also agree that there's cases where you don't need that acknowledgement, and maybe there's or negative acknowledgement, and maybe there's a way to convey that at the subscription level. I don't know, but I think there are use cases where you definitely want, as an application developer running an application server, not to do too much there because you're delegated that to the push server.
So I'm actually wondering whether there's actually a middle ground here. Let me try this one on for size. Microsoft wants to provide this service just to call you out. You're going to give up at some point because of this bad behavior. And you're going to send a NAC. Google are going to say, well, if I crash the phone and I do it again and I do it again for the next 4 weeks, that's cool. Not my problem. I'm not going to give up. And so they never have to send a NAC in that situation. If you never actually give up as a result of not being able to deliver a message, then you never actually have to worry about sending a NAC and you can be compliant with the protocol.
This is Elio again from Microsoft. In general, I think that the conditions with which this NAC can be generated can be multiple than more than one. We have some, and one way is that we could make it generic, meaning that you could have like some effectively some act with codes and only prescribe some of those. But like you're saying, Google will implement some and we will implement others. What is in general, our service will provide this service as far, and we would like it to be something that people can depend on. One final thing, as far as the scenario goes, in the scenarios that we're targeting for IoT, where the user agents are actually really, really small things, they could potentially have like Ks of RAM. The fact that, when you have a population of like thousands, hundreds of thousands of those devices, you really want to know if something happens sometimes before 4 weeks have passed or things like that. You want to know if you're effectively like crippling your devices with specific messages, and you want to know exactly what device, because that could change depending on many things, and you want to correlate that information with the specific firmware version that you have on that device, so on and so forth.
One small comment, just my concern is what will application server do when they get a knock? If they send again and crash the user agent or whatever again, that's pretty bad. And they get infinite loop.
We would have to include advice on that point, I think.
And if they don't, then what's the point?
They have to find other ways to get that information.
Because they will not know what happened. I mean, there may be many reasons to solve crash. Right. So it's basically useless information.
So one of the pieces of advice that we can give here is that application servers should not attempt to resend the exact same message to the device. Now, one of the examples that Elio gave me when we were talking about this, and I took a little while to be convinced that this was even necessary, was that you send a particular message saying, here's a state update or something like that, and it caused an explosion of some form or other. You don't know exactly what happened, although you can actually provide some information from the push service in the body of the response. It's not machine processable necessarily, but it could be read by a human and passed out if necessary. But in that situation, they would receive the NAC, go, damn, I can't do an incremental state update on this device. I'm going to send a minimal message down to the device that I know hits sort of fail-safe code that says, you're out of sync. Restart. And then that would trigger a different set of logic, and maybe it wouldn't crash that time. And then, so you do actually have options there. And maybe you can just flag it in your database and have your ops people have a look at it, because you've got 10,000 IoT devices, and maybe there's a dead light switch that someone needs to go out and replace a battery in or something like that.
Joe Hildebrand, I wonder if the goal of the working group is clear enough here in terms of the level of reliability we're trying to achieve from what have we signed up for question. Yep. And I'm carefully saying this from the floor, not from the chair spot, because I don't want to, I just want to make sure that we're all on the same page with that. Yeah.
So our charter leaves this item open.
I get that.
Absolutely. We need to come to some sort of consensus about where we stand on this.
Agree. But I think this particular question of what are we trying to solve, and in this the specific edge of it is likely to come up 8 more times. So if we can't get some sort of consensus on this one as sort of the canary in the coal mine, we're going to keep having the same conversation over and over again. So I'm wondering if there's sort of any flexibility on either of the sides to see, hey, can I see the world the other way? What would that mean for me? That kind of thing. Like, could you live with, is this the whole thing's not worth doing if you can't have this particular act and the 8 more that we're going to find later? Or is this not worth doing if I have to send all of these acts and the 8 more later? Yeah.
So I think as we talk this through, I think I saw some movement.
From the last word of Elliot saying IoT, I think I got his point now. If we assume the user agent, it's not push service code, but it's developer of application server, now the NAC makes sense because they have no idea that they crashed because of the NAC, and I can tell the server. But that's a different use case. But how many of these are
really considered as the primary one? But, I mean, you're talking to phones, right? And you're talking to applications developed on phones where you have a server component, you have it, and in the web context, it's the same thing. So
yeah, because the only other way would be the content, and if the content, then the app should tell the user agent, hey, this was bad for me. But if you can tell the user agent, then you can tell application server.
There's another example that I know you'll love, and that is that the message was encrypted incorrectly and dropped on the floor.
Let's push this for later.
So am I hearing that you could probably live with the NACs?
So yeah, but we need, the protocol needs to be accommodating for the two very different use cases, right? There are two worlds here. One world in which there is a central intelligence on the device, on the end device, that dispatch the messages. This is the case of GCM today. And there's another one which is more likely an IoT use case where actually you might have multiple connections to the push service from the same device because the apps act on their own. We need to realize, in one case, NAC makes sense, in the other it doesn't. So.
Alid, does that work for you? I'm seeing a nod. Okay. So that was a fantastic conversation. It sounded like we started to understand each other a little better.
So I think we're kind of here. And there's some details to work through, and we have to talk through the TTL0 thing in some more detail. And this is actually kind of in the draft, but it needs a lot more meat around it. So what we'll do is we'll iterate on that and send some text to the list and see how we go.
Some of the guys are here just today and then tomorrow. I mean, it would be good for you guys to just get together and
already
talk to you. Okay, good, great.
Oh, I have more. All right, we covered that. I just wanted to put this up here because we need to tile the entire square. And there's a corner out there that looks approximately like this. It seems ludicrous, but but it turns out that in a number of these services, the acknowledgements carry some information. And it turns out that you have this symmetry that goes on. And then you end up with this wonderful infinite recursion problem to about 3 iterations or something like that. I have a position on this one. Let's not worry about this for now. There are things we can do about this potentially in the future. Maybe we have foreclosed on some of those options, and I'm not particularly sad about that, but that's where we are. It's software. It's protocol. We can fix it.
We're talking
Dan Drutza. I think this should be covered. I mean, technically, if you got the acknowledgement, you can send a different message. Say, so from that perspective, the application server is aware of the acknowledgement. It sends the identifier of the acknowledgement.
All right. Since you asked, I will share with you my alternative,
No.
which I think is superior.
Okay.
So in the alternative,
Actually, you know what? Let's put a pin in this.
Okay,
sure.
And come back to it later because I think there are places where we can make progress today, if that's
Sure.
okay. So
the
if
alternative
you're about
sort
to
of
suggest TCP over web push, then maybe we can move on.
no, it's
Oh, okay.
actually you're pretty close actually, but it doesn't go that bad.
All right.
So
let's not talk about
there
it.
is a simple-
You guys get together offline.
there is a
and move on
simple
next.
answer to that I think covers this case in a much more elegant fashion.
Yeah, to the list.
I'll send it to the list. It's not actually all that bad, and I think that's all I've got because it stops going forward at this point.
We have time left at the end. We can talk about it.
Sure. It's fun talking about these things. You'll notice I put that one at the end of that deck. bit of a relief. So what do we want to talk about now? There were.
You want to do this, or you want to go through the?
Oh, this one's going to be fun. I think we need some time for this.
Okay, so maybe not today.
I would like to resolve this one today.
We got.
I think we have a shot at it.
We got 20 minutes.
We've got some people that
Well,
know what we're talking about here.
We have 20 total minutes? Or
There's
20 minutes?
only a couple
20
of slides
minutes
here.
just for this.
All right. Yeah.
There's a handful of slides, and I think we can work through this. So there's a number of questions I want answered out of this. The high order bit is, are we interested in adopting the proposal that I have put forth for crypto? And then there's some questions that flow on from that. So, oh, I have the means. There we go again. Look at that. So let me first summarize what we have. So based on some review and some feedback from a bunch of people, I've updated the encryption draft to cover, it actually tracks TLS 1.3 to a large extent. We actually have a whole lot more certainty about the record layer in TLS 1.3. So the record structure in the base encryption draft that I've talked about in HTTP has been updated to match TLS 1.3. And there were some people concerned about the original structure. Funnily enough, there were some parallel concerns raised on this and concerns raised in TLS 1.3 that were both addressed in the same fashion. For push, I have simplified the record structure. And there were some concerns from David Benjamin at Google, who was looking at analyzing this whole thing, and we had an interesting discussion on this point. He didn't like the idea that someone generating a push message might be able to split the push message up into multiple records, given that it's only 4K. It really doesn't make sense to run the AEAD multiple times and then have to worry about truncation and all sorts of other funny things. So I have required that someone sending a push message send a single record, and that they don't run the trap of truncation. So they set a very large value for the record size. You can actually set the record size equal to the encrypted message size, and you can avoid all sorts of problems. But there's only one value that you have to avoid, which is that value at the bottom. And that value indicates that you potentially have a truncation. And anyone receiving one of those is obligated to reject it. So those are the changes. They're not particularly extensive, as you can see. There's a few little tweaks to the text, and I think I've fixed some spelling errors and all sorts of other wonderful things. So I have 2 questions, and then we'll talk about adoption. Does this do it justice? That's my question. I'm not going to attempt to defend one or other at this point, except to note that P256 seems to enjoy better deployment. It's been out there for quite a bit longer. 25519 appears to be better because the CFRG told us so. I mean, why would they do it if it wasn't? So we have a choice. And that choice is the difference of one word or another. And I've asked Mike, and I've asked Peter, and I've asked Matt, I think, as well, to offer their opinions on this subject. And I think there might have been a few other lurkers around here who actually know what they're talking about too.
Mike Jones, Microsoft. I'm going to do something which is unusual, so I want to call it out. Right now, I am speaking for the Microsoft Corporation, not me as an individual. Microsoft believes that for this use case right now, because P256 is so much more widely deployed, that that's the right choice.
Okay, this is Peter from Google. As I mentioned earlier about the prototype which we implemented, we decided to implement Curve 25519 as opposed to P256.
Mike, don't go too far away. Sorry, I just want to make sure he didn't run all. Mike, don't go all the way back to your seat. I'm going to have a question for you. Okay, yeah. Sorry, I apologize for interrupting.
the primary reason that we chose for this from Google Chrome's perspective, this is the WebPush protocol, and my main interest is Chrome as a browser and delivering this as a service to web developers, is that the vast majority of websites, as opposed to applications native to a phone or to an operating system, use interpreted languages on the server side, such as PHP and Python, which don't have good availability of any of these features altogether. To illustrate this, for example, in PHP, which is a very popular language for websites, it advertises availability of AES-GCM, but it actually returns AES-GCM without the authentication tag, so it's just completely pointless. From the point of adoption in these languages, there is little, it's going to be hard. It's going to be hard for people working in these languages to adopt the encryption draft altogether. And we don't think that we need to make consensuses or that we need to choose a curve like P256 with better deployment if there's going to be large adoption issues anyway. And we may as well choose to go for the better option.
Just a question. Do you think there's anything that we could do to improve the deployment chance here? Is there any crypto we could apply that would work?
So at Google, we actually implemented the Curve 25519 Donna implementation, and this is available as extensions for both PHP and Python, together with implementations in many other languages. As opposed to AES-GCM, that's a much harder problem because that's much harder to implement. That's timing sensitive, and we don't want developers to create their own implementation there. Whereas for Curve 25519, it's much easier to implement a correct implementation, different from P256, given that it's a simpler curve.
And that actually goes to the point here. That's one of the reasons that it's been chosen by the CFRG. Performance and idiot-proof, I think, was the...
Matt Miller. So, at least in my experience of working with these things, I've usually found P256 available because it's an OpenSSL. And it's in a couple other core crypto libraries that get passed around a lot that, at least for the things I deal with, most of my stuff is in Node and Python. Both of those, there are pretty decent mappings from OpenSSL onto them.
Yeah, the GCM mapping is awful, by the way, but it does work.
Well, yeah. At least in the latest Node, it's not horrible. You get the authentication tag. But there's also this incredibly large base of Java applications, Java servers, where P256 is there in various flavors already. So at least from my perspective, as somebody that's written a lot of server code that's got to get pushed around, 256 is there and 255.519 isn't quite.
I think Matt actually answered the question I was going to ask you, Mike. So that was if I was going to have to write new code anyway for either of these, then shouldn't we use the better one? And the answer is because it's an OpenSSL and in the Java. All right, I understand. It's unfortunate, but at least I understand.
And this is available in all of the Microsoft crypto libraries as well. And that was a point you should make, I think.
Yeah, Mike Jones, just speaking as me. I wanted to respond to your comment about Python because one of the people I work with very closely, Roland Hedberg in Sweden, wrote an OpenID Connect test suite in Python that uses standardly available libraries and uses all these stuff and works in Ruby. I mean, one of the things we did in the Jose working group when deciding what algorithms to recommend and not is we did a really comprehensive survey 2 years ago of what was deployed in what development tools. And this was pretty good. I mean, RSA was ubiquitous. I can temporarily at least join your working group mailing list and forward that data.
Or you can send it to one of the many people.
Martin, why don't I just send it to you?
I've seen it on a number of occasions. It's an excellent matrix. It covers libraries, platforms, all sorts of algorithms, more than we need here. But it was a pretty thorough survey.
It's data.
So, and then we could take that as a starting point. Thank you very much, Mike. We could take that as a starting point if there are people that want to revisit any of the findings that are in there because we're a couple of years later. It would be completely appropriate to do so without derailing the thought.
Sure.
So we don't have to make a decision on this today.
We don't have to make a decision. I just want to get this in front of people, get that information out.
Is anybody else incensed about this? Go ahead, Mike.
And if you get new data, I'd love to have it.
Absolutely. Oh, sorry, one more thing while you're there. Are you planning to use that same approach for COSI?
I think the use cases are different enough that it'll be different algorithms. I hope we can use that approach in terms of what to recommend for those use cases.
So if you do happen to update any of those findings, can you please also send those over to us?
Great.
Oh, and Mike, one last one. You actually have a fair bit of knowledge of the deployment of JWE, which I think is probably most pertinent to this. Can you speak somewhat to JWE's deployment in language reach and all those sorts of other things?
There's great implementations in Java, .NET, Python, Ruby. I think there's Scala, there's C, there's PHP. I have real data I could point you to on that too.
That would be lovely as well.
That would be awesome. Because one reason that I asked for that is when we sat down and talked about the encryption stuff, we worked out that the record layer, the GCM application, is merely a profile of JWE if you think about it from some perspectives. You can provide a particular header to JWE and then just take the header away again and drop the message payload in. So
and encrypting, if that's all you're doing,
that's all we're doing.
You don't need a library. You just, printf together your strings and you're good.
We don't like to recommend that to many people.
I get that.
You're right.
It is that easy.
Yeah. In this case, that's what AEADs are for. So let's get that information. We'll have the discussion on the list and try to come to some sort of conclusion on that. All right, 5 minutes. David Benjamin raised this issue. I may have trouble explaining the details of this, but to the extent that a user agent is able to authenticate the application server that sent a message, we rely on two things. We rely on the fact that the URI that the application server uses is only given to that application server and contains sufficient entropy that it would be hard for anyone who was not actually given the URI to guess. And we rely on the fact that we also have this asymmetric key pair that we give them the public key for, and only they are the ones that get that. And ciphering a message toward that in Diffie-Hellman share is difficult without actually knowing what that is. So David Benjamin raised the concern that, well, URLs leak and they're actually known to the push service, and implementations don't treat public keys with the sort of care that we might like, and that leaves them somewhat exposed to the possibility of generating timing side channels in the handling and all sorts of other things, such that bits from the public key might leak, such that they could be recovered by someone who wanted to send a message to you. Now, to the extent that you consider this important, should we add some additional authentication mechanism that doesn't rely on any of these properties and their inherent weaknesses, so that we could say at the receiving end, yes, this message really did come from the person who I gave this information out to. And so what this would entail would be a bucket of bits would be given alongside the URI and the Diffie-Hellman share to the application server, and the application server would carefully ship that up to its instance in the cloud. Now, it wouldn't necessarily need to be a bucket of bits that needs careful encoding. One of the concerns that David raised was that doing something like base 64 encoding is not constant time, so you don't do it on private keying material. That's a comment for Jose, by the way. And you would give them maybe a string, and you would take that string and you would shove that into a hash map on the application server side over some piece of information that was unique to the message. It could be the salt, it could be the public key that it's using, it could be anything, as long as it's somehow bound to these properties, such that the application server can prove knowledge of this secret, whatever it happens to be, and therefore enable the user agent to authenticate that guy.
Are there places where the public key might leak, but this information wouldn't leak?
Timing side channels in the generation of the Diffie-Hellman shares on the application server. I mean, this is, from my perspective, I thought this was a bit of a long bow, but I wanted to give this a fair hearing because I think this is, it is actually a concern. It is a genuine concern. The question is there enough of a concern here to worry about it? And
is the data we're protecting
that valuable?
Valuable enough to make the attack worthwhile.
Right. And so you could spend some number of bits on authenticating this. And we could use truncated hash maps if you're really concerned about the space. But it would require additional machinery and additional bytes on the wire.
Any opinions from the room?
Well, as you know, for GCM, we plan to require Christine, Google. For GCM and for our implementation, we plan to require server authentication one way or another. I don't think we have any path where we wouldn't have server authentication. Not sure which form, and it can be in a different draft and a different discussion. But I think it's critical for many, and we discussed in the mailing list different reasons.
Fine. So maybe we can just park this one. If no one has any strong feelings on it, we can take a look at the proposal that I think Google are going to come up with and see whether or not we can use that aspect of it to deal with this. It may be the case that is insufficient for the case that David asks about. You want to ask a question?
No, I want to tell you you're out of time.
That's all I have.
Good. Perfect. Well timed. Okay. Hervé?
So I'm Hervé Renan from Canon, and I would like to talk about energy requirements for WebPush. So next slide, please. So we've got devices, and we would like them to receive a notification from the clouds or from the servers. For example, for a camera to receive notification from a photo sharing service, or for a printer to receive notification from a server when there are new files or new documents to print. However, we have strong energy requirements. For one, we want to get energy efficient certifications, such as an Energy Star, or there may even be a regulation imposing us to have a very low energy consumption. And the problem with notifications is that in many of our products, they will use wireless communication, and this uses battery. WebPush is very good for us because it's efficient notifications. We don't have to do polling every few seconds or even every few minutes to get to see if there is a new notification. But we think this could be improved further. So next slide, please. So for first thing is the problem of TCP keep alive. It's required by some the intermediaries to keep the connection open, and from a paper from 2011 from Wang, they found that in 15% of ISPs have a timeout less than 10 minutes. I think the study was done in the US, and this increases energy consumption by 10%. So for us, from our point of view, we don't want that. A second problem is HTTP2 ping. So the ping could be used, for example, for a push server to check if the TCP connection, or more likely the HTTP2 connection, is still alive. And it could generate unnecessary traffic, increasing energy consumption. So we would ensure that this doesn't happen with web push. And last thing is a consecutive notification. We think that there should be grouped to use the same active period of the wireless subsystem, so that we don't have, as in the top, every notification waking the wireless subsystem, letting it go to sleep again, and then the next notification waking it again. So it could be useful to have something similar to the TCP NIDL algorithm to group several notifications in one waking period of the wireless subsystem. So that's it. We are welcome to source or any comments on this.
Joe Hildebrand from Floor. Can you go back to the, keep going back there. Are you suggesting that TCP keep alives would actually be used? All right, so in practice, Matt's about to stand up behind me and correct me, but like we've found in XMPP that these are basically completely useless in practice. Yeah, it's not so. If you need to do this, you basically have to do it up at the application layer, have something that you can send and probe. Even worse, you need to get a response back, because otherwise you're waiting for something like 11 or 17 minutes to know that the TCP socket is dead when all the timers time out. So this is one of those things that there's no good solution for, unfortunately, unless you've got some help from the network.
Yes, and probably it's probably not a good venue to solve this problem.
Yeah, so this is really interesting. I'm playing on battery for many years. On GCM, we chased every single operator in this planet to raise that timeout. Some of them, they're still not playing with us, but the best ones, we have an hour keep alive. The best solution would be maybe in some years from now, if IPv6 is everywhere, then we can just point to the device. No need for heartbeats. There's other batching that is done. There are also options like priority, because not everything you want to wait to delay. Maybe for the camera, it's okay to wait for every message, right? But if you have a voice over IP call, you want to be instantaneous. Yeah. But there'll be a lot of things that can be done. I would say at the push service implementation that does optimization for battery.
Matt Miller. So as Joe was alluding, what we have found with devices is TCP keep alive was useless. And what we also found is that usually something between our server and the client would kill things within 30 seconds. So about every 30 seconds, we would have to send something. And it seemed to be very universal. Now, for a push service with a camera back to a very well-known device, that's probably much, much, much less of a concern. And if we could do that, that'd be great. But especially from your application server to the device, you're better off looking at killing that connection and relying on the push.
And the worst of those, this is Joe, pretend I'm on the floor. The worst of those wouldn't send, offend, or reset when they drop the state for the connection. And so the socket was just dead, but you had no way of knowing until it was 17 minutes from now, and too bad. And so both sides needed to be sending these keep alives in order to find out that the socket had died. It was horrible.
Yeah, exactly that. And it really was every 30 seconds.
Yeah.
Now, that's between the application server and the client. Again, if you can rely on some other way of doing the notifications that doesn't require that channel, like the application server to the push server is well established enough. I mean, most people can get that network set up that it's not an issue, right? And they don't have to worry about keep alive. They don't have to worry about the white space pings is what we used in XMPP.
We need to cut the line also. Okay. So if we can move along. Sorry.
So anyhow, I would just say don't rely on keep alive. It'd be better at least at an application perspective, from an application client to an application server. If that's a concern, then kill your socket and let the push deal with it.
Yep.
Question, Google. Just one small comment, and I don't know how we missed this in the previous discussions. Different ports have different timeouts, and we need to discuss not using 443 for web push because, I mean.
Yeah. Can you make sure that we capture that as an action item, please? All right. Thank you very much.
And keep alive are bad.
Yeah. All right, Fabio. We're running just a hair behind.
Hi, I'm Fabio Chiusi from Cisco. Can you go to? I'll try to be quick. Could you center it? Is there any way to? So actually, the main purpose of this draft is I'd like to spark a discussion on a topic that, at least in my view, is becoming increasingly urgent. Essentially, I'd like to find some answer on a question. There are a number of use cases that are emerging that could benefit of web push, and they are increasingly popular, and there is an increasing demand from customers to provide solution for them. Currently, web push, since it's centered around the notion of subscription, makes covering this type of use cases quite awkward. So one question that I'd like to ask the working group is, could we come up with a sort of a looser notion of subscription that would help in covering these use cases? If you go to the next slide. So, yeah, currently the web push is centered, and the notion of subscription is the foundation for web push. And these are for extremely good reasons. So there is no question on that. However, it's also true that in the use cases, and I'll give you a few examples, some of those reasons could conceivably be using up and helping in covering those use cases. So I'm just giving 4 examples. I think there are more, but these ones are the ones that we are currently dealing with. First one is simply the problem of waking up dormant UEs, especially in the context of small cell deployment. for example, LTE is more cells. The issue of waking up a UE is as a very poor solution right now. And in some of our pilots, we're actually using web push with moderate success. It would be actually a much brighter success if we wouldn't require the subscription, or we would have a bit of a different notion of a subscription. The other important use case is local alarms, and it's not just the building is on fire. It can be a missing child. Or, there are a number of situations where the value of information, or actually the cost of not getting information, is so high that it preempts anything. So in those situations, the user would, for example, give up some privacy, for example, in exchange of being informed. So alarms and notification is a prominent example of that. There are a few other use cases. If you go to the next. A similar situation is in a certain environment, in particular in smart buildings or venues, where the user has a clear expectation that entering the building, there is some type of provider that actually owns the connectivity in that building and provides services through that building. So in those situations, the user expectation might be looser in terms of maintaining privacy. Finally, one issue that we are seeing with the current notion of subscription is the fact that users are sensitive to the global volume of pushes. And right now it's very difficult for us to police or to regulate the global volume across applications that are hitting a user. And so we need two things. One, sort of a global notion of web push type of traffic, and two, a notion of fairness on how you would regulate a different application on that. So I guess this is the question I'd like to pose to the work group. Is there any, are there any of these things reasonable? So, for example, could we define subscription models that are location dependent? So, let's say you enter in a certain environment or a building, and your subscription might operate differently, or might be looser, or maybe you don't need to subscribe to each and every application.
No, I was just waiting for you to finish, and then I'll make my comment.
Okay. So that's one possibility. Or could we define, I call them push authorities, or subscription authorities, that would, and this have to be trusted entities, that would actually regulate the traffic in exchange of the user accepting not to have an explicit subscription. The user would expect that it would not be hit by 300 messages, or there could be a frequency regulation, or some type of mechanism in that fashion. And if you have this mechanism, then the notion of having it applied globally and controlling the user could be also a benefit from that. We could use it to actually provide a
so we got like 1 minute left. 1 minute left. So
yeah. So I think so next step, yeah. I would like to start the discussion on these topics and gather feedback and work on some type of subscription model with user.
Dendrota. Actually, I agree with all the use cases. The only problem is that there is a different terminology for them, and they're called broadcast. And you're basically doing client-side subscription. And it probably is a different pattern. And I believe it has a totally different set of issues associated with them, because it's different. So if we look at it, this subscription-less is broadcast. So that's what I think. I think you described all these cases that apply to broadcast, and we got LT broadcast. We do, Amber Alerts, all those kinds of things. So it could be just a different.
Well, okay, guys, that time, we're out of time. So please discuss on the list.
I've achieved my goal.
Great.
Start the discussion.
Okay. And you guys can talk to each other after the meeting. So we got 1 minute left. I just wanna so when we considered adopting the protocol draft, we actually decided to not include the encryption as part of the draft. And I guess what I want to ask is, do people have any issues if you do decide to, include the encryption draft as part of the core draft, or do we want to create another milestone for the encryption draft? Elliot?
Hi, this is Elliot from Microsoft. Besides I want to raise the problem of some IoT cases where, in general, I think that if, like Francisco was saying earlier, you have that the device is actually part of the application, so the user agent is not an intermediate notion. There is effectively no need for an encryption standard. Now, I'm actually not opposed to it in any way. However, there could be some cases where we're mandating certain crypto algorithm on a device which could be constrained. It could actually pose a problem. So that's just that is basically.
Okay.
Darshak Thakur, Cable Labs. So let me first ask a clarifying question. When you say include it in the code, are you talking about including in the code draft, or have another draft that is actually a
So when I say include it, it means to include it in the core protocol draft, right? I mean, whether we're going to mandate the usage of it will be a different story, right?
So is the option to have it be delivered with the code draft, but as a separate draft available? I mean, would that be an option to consider?
I mean,
Google, I speak for the three of us. I think we're fine with putting in the code draft. I suppose Elliot's thought about maybe we can think of allowing as an optional no encryption in the protocol. I think we'll have a lot of benefits.
Yes, and Thompson, I don't actually mind where it lives. There may be some editorial conveniences that we can get by having the split. I don't know. This will be mandatory for the W3C spec, but we can make a separate choice regarding must use or not here for the protocol uses, because we do actually have a broader set of use cases that people are bringing in here. That said, if we don't make it mandatory to use, we create ourselves a raft of security issues that we have to deal with. And the question is whether you want that particular flavor of pain.
So kind of a line after Leah. Lisa? Wow.
Must be.
Yeah. Matt Miller. It might be interesting to think, well, still making this mandatory, because like you said, the W3C, and there's a whole raft of cases where in crypto here is going to be absolutely mandatory. It might be worth thinking of it as a separate draft to allow for some freedom as as the state of cryptography improves, that we might want to give ourselves some breathing room. We specify something now at one level, we can update later as things improve.
Alyssa Cooper. I think I have no opinion about how you organize your drafts, but from a sort of process perspective, I imagine that there's very likely to be a normative reference from the core spec to the encryption spec, and also not just that they would sort of need to be eventually published at the same time, but that when people start reviewing this, outside the working group and in the IESG, they will want to know the details of how the message encryption works, and so I think you can expect them to sort of progress together regardless of whether you put them together or not.
So it's likely that the two things of being able to have a separate editor for this chunk of the draft and then being able to parallelize the work a little bit, I think probably we ought to keep them separate for the moment. We can always recombine them later if we decide that it's easier to read or process or whatever. Yeah, so we don't have to make a decision just yet. We may also decide at the end that Matt's point of keeping it separate allows us to rev the crypto is the compelling point. So we might as well just keep them separate for the moment, as long as you don't mind if we add another.
No, I think it's totally fine. I'm just saying I don't expect to get the protocol draft published.
No,
without
we won't send anything to the IESG without having both.
Okay, great, thanks.
I'll also note from a process perspective, you can have multiple drafts satisfy the same milestone if you want to go.
Yeah,
want to avoid creating more milestones.
That's probably true. Well, we know a guy who can help us. Yeah. All right.
Hey guys, thank you very much.
If there's anybody that didn't sign the blue sheet, please come get it. And I'm looking for the other clipboard. Oh, it's right there. Okay. That's one.
Blue sheets, anyone?
Yeah.